Hello. Let's use Ember wherever you feel like, and I do mean everywhere. So in case you didn't catch it, I go by Preston in real life. This is how you can find me online. I'm Novox Populi. The website at the QR code has a list of links: Blue Sky, Mastodon, Twitter, GitHub, etc. If you can't find me somewhere, let me know, and then you'll have found me. All right, I play some video games. Here are some ones that I'm particularly obsessed with right now. And I first got into K-pop back in 2012, but it kind of faded for a while. K-pop Demon Hunters has renewed my interest in K-pop, and that's exciting because it's such a good movie. If you haven't seen it yet, somehow, please go watch it. This is my favorite person. I would not be here without her, nor chronically online without her understanding and grace. So I'm employed by Audit Board. You can find out more at the link here. There's some hiring going on, though I don't exactly know what country specifically. This changes apparently every time I look. When I was writing this slide, I saw openings outside the US in the UK and Canada. Last year, I shared this slide about the breakdown of our 3 main repos, what languages or file types are used in each, and the package breakdown in the front-end repo. 1 year later, things have changed significantly. This little footnote here is very tiny, but it just shows how I calculated the numbers. It's not important, but if folks like to know that kind of thing, this information will be up later. And that'll be true for the upcoming next slides as well. But yeah, while this is the smallest of the 3 repos, it's grown by 150% over the last year, but there's no Ember in it. This repo is significantly bigger, starting last year at about 1 million lines, but only growing by 32% overall to 1.4 million lines. But these lines are of higher value, though, due to all being TypeScript. There's still no Ember here. This repo has all of the Ember. Some interesting things about the numbers in this table. The total number of lines only went up by 50%. However, adding 1 million lines of code in 1 year just feels really bonkers. And fun fact, during this time, the codebase completely migrated all components, route templates, and rendering tests to GJS and GTS. We have no more handlebars. Also, during this time, all but one of the apps in the repo are now running Vite, and that last app has a PR that just went green before I left for Belgium. Yeah, and best of all, the code is still primarily handcrafted, a little machine-assisted, but we use every tool available to produce values for customers. No vibin'. And for fun, last year I said that my contributions in total were unfortunately still net positive. This year that's still the case, but I'm quickly approaching 0. And I really like the idea that maybe next year I might be able to achieve my goal of removing more code than I've added to the code base. This is a silly metric, but I think it's fun. Producing more value with less code is the dream. So enough stats. Let's get to putting Ember places. What does it mean to put Ember or use Ember everywhere? This is what you're familiar with. Some may refer to this as Ember New, or you perhaps, like me, have developed some preferences. Yesterday, we saw how we can make other frameworks work in Ember. And later today, we'll see how the Ember Vite plugin enables integration in the opposite direction. So what more can we do? So much more. There are 2 things you're going to need to know, and not necessarily in this order, but how to boot an application. This is just going to be a super quick overview since I think we're going in depth on this later today. How to patch Ember. Perhaps Ember doesn't do what you want it to do, and you're very motivated to change its behavior, for experimentation or proof of concept purposes, of course. We're also going to need to quickly touch on how rendering works in Ember today, a 1,000-mile-high deep dive into how it works. And very quickly, how to debug when you don't know where to start. These are kind of somewhat unrelated topics, but it'll all become important momentarily. I bring them up because some of this stuff feels more complicated than it is. And for me especially, I have to fight talking myself out of just even trying, mustering up that activation energy to get started, and realize that I can do whatever my task is. My hope after going through all of this is that you feel empowered to do the same. We all have to debug for our jobs, but there are some debug tools that seem not as common as I would like to see in web dev. So I wanted to share how I debug, because when you have too much blood in your caffeine system, you gotta go fast. So in all of debugging, we have 3 techniques, which have various ways of using and interacting with your code: logging, breakpoints, and REPLs. However, how you go about using these 3 techniques can greatly change how effective you are at figuring out what is going on. So console.log. We don't want to do this. And I don't mean never, but bear with me. There are a few reasons. It requires a code change in order to see things. If your code uses a build, it will require a rebuild of the change code. And if your code is in the browser and you don't have hot module reloading, you have to wait for a full browser refresh. And all those network requests if you have a large Vite app. So in the browser's sources or debugger panel, you want to start with right-clicking the gutter here. And we're presented with a little inline modal of where we can enter what we want to log. And we can choose if we want the stack printed. I like having the stack trace, but I understand it can often be redundant and noisy depending on how folks like to debug. This is what the created log point looks like. It's a little pink flag. And here's what it looks like when printed. The console has a similar color indicator to the left. It logs what we told it to. On the right, it tells us where the log point is. And we have a stack for how we got to compiler TS on line 49. Now, if you're unable to find code that's evaluated, console log is still useful. But I find this technique to be most useful when I have to figure out how a particular function is getting called, and I expect it to be called multiple times, and I don't want to pause all the time because it's like too much interruption. And I don't need to change the source code to find out what information I need to find out. But speaking of pausing, next up is the debugger. Very similarly, we don't want to do this because it requires a code change. It's going to make our code build, and we're going to have to wait for all those network requests in the browser. Similarly, with a log point, we'll right-click the gutter on the left side of the file, and we'll click Add Condition. We're presented with a little modal where we can specify our condition. I often don't always want to pause, but I find it useful if I kind of know what data is getting me into trouble, so I can look at just that specific situation in the sample of control flow for when that gets hit, like if it's a function that gets hit multiple times frequently. So in this case, maybe this is when the text includes @tracked. This is what it looks like once you set it. It's like an orange or a yellow flag. And here's what it looks like when execution pauses at that breakpoint. So here's some more of the stack. We'll come back to this in a bit and dive deeper. Maybe you've seen this and got scared. Hopefully there will be no more fears after this. But this can be done in VS Code as well. The default configuration is very bad, so we need to change it. Though I only like debugging with VS Code in Node because I found ways of configuring VS Code to hook up to the browser to be very brittle, which is true outside of Ember. But I also believe the browser arguably has better debug tools anyway. For node debugging, though, this is a great tool as it'll automatically attach to every subprocess spawned by the thing you're wanting to inspect. So here's what you have to do. First is change the auto-attach filter. You always want all processes attached when debugging. A lot of tools will take advantage of the number of cores available on your machine, so you'll want to attach and debug all of them. Next, we need to completely delete the auto-attach smart pattern defaults. This is maybe unneeded due to the previous setting being set to always, but filtering out node modules is silly, as node modules are often where we need to debug. Normally, you'll want to use the JavaScript debug terminal, though there are ways to set up your default terminal to have debugging as well. Lastly, and this has trolled me for the longest time, if you configure node options, you'll need to make sure that you forward the node options because VS Code also configures node options on init of your terminal. And VS Code has log points, breakpoints, conditional breakpoints. It's good stuff. The debugger is actually so good, it's the only reason I don't spend 100% of my coding time in NeoVim, which is the best editor. Our last debugging tool is REPLs. This can be helpful for minimally reproducing problems. And chances are, if you've interacted with me in the Discord about reactivity or a data flow situation, I may have asked you if you were able to reproduce the problem in a REPL. This also has some nice benefits. It's minimal, there is no fluff or distractions in the code, it's easily shareable. The code communicates more clearly and accurately than written or spoken word, and this is my preference for certain types of problems, because words are hard, and code is just code. Lastly, it composes nicely with previously mentioned debugging techniques as well. Okay, so now that everyone here is experts at debugging, let's say you discover something you want to change, something you want to test out in your project. We can patch it locally before we commit to a PR. Big disclaimer here though, patching is something you have to maintain. I consider patches in big applications as tech debt. Sometimes this tech debt is necessary. If you instead submit a pull request, you won't have to maintain the code. And this is the ideal. If you keep the patch around forever, you've potentially accidentally decided it's more worth it to maintain your change forever yourself rather than trick a maintainer to do it for you. If you use pnpm, patching is super easy. It's just 2 commands. Now, you may be thinking, Ember's perfect. It has no flaws. What could I possibly want to patch? Don't you worry. I'll show you. First, we need to get a sense of what's in Ember. These are all the packages. There's quite a few. And we'll come back to patching momentarily, but first we need to talk about rendering. So what happens when this button is clicked? We know the increment function will get called here, and that increment function increments this.count. But then why does a change in count cause the template to be updated? Previous debugging techniques are sort of inside-out debugging, where we start at a specific line of code and then inspect the surrounding areas to work back up the stack to figure out where something went wrong. The other way to figure out what's going on and what I'm going to call outside-in debugging, where we start with our code and dive into the unknown down the rabbit hole. So here's our starting component, a counter. With our knowledge of how class properties work, we can combine previous debugging knowledge to set this up. We don't have to search around in Ember and Glimmer codebases to understand what's going on, though we certainly could. A less error-prone way of discovering what happens can be done by renaming our tracked property and defining a getter-setter pair that intercepts the read and writes to the tracked property. Now, in the browser's debug tools, we can put a breakpoint there in the compiled output. Oh, and in case anyone is wondering, I totally could have done this live, but I don't trust myself to remain on time and a functioning human when doing improv debugging. So if we click the button, our breakpoint will be hit due to increment setting the count, and because we know this assignment is special. We can click Step In to see where we end up. Once we step into the assignment, we find ourselves within this descriptor for field function. If this is your first time here, you may think, that's not tracked, which you're correct. But if we scroll up a bit, you'll see tracked, and that it calls the descriptor for field function in a couple places. We can be reassured that we are still in the right place. But coming back to where our paused execution is, let's step in. Here we are. Now, we'll need to keep stepping in for a while. For now, let's dive into dirty tag 4. At this point, if you happen to be paying enough attention to the surrounding code, you may have noticed a fair number of optimizations we can make. Not to worry. A bunch of us are in the middle of deprecating all of Ember Classic, so we can clean this up and gain some performance back. Here is dirty tag 4. We want to get to the last line here. This first part of the function is just validation. In particular, we want to get to what was off screen on the previous slide. We have this all caps dirty tag here, and this is what we're going to step into next. And if we hover over this function, we'll see it's actually an alias. This is important because sometimes the call site name doesn't match the definition name. So here we have more validation, and the interesting part is at the end here, schedule revalidate. This is interesting because up until now, we haven't encountered anything that sounds like a side effectful behavior. Now, why are we looking for a side effectful behavior? Synchronizing the DOM or any renderer is a side effect. So this is just a bit of indirection, but for some fun context, set global context is how we configure the Glimmer VM, since Glimmer was originally going to be a separate project. Stepping in, we'll see some more indirection, so we'll step in again. And here it sort of looks like we're at the end of the line, so there must be some mechanism by which re-rendering happens. This is actually a key difference between Ember and other frameworks that decide to render via the public API versions of their effect primitives. Other frameworks will try to push out updates eagerly via effects, or maybe washers if you're familiar with TC39 signals. We don't want to do that. We don't want to write to the DOM via eager effects because we frequently run into situations where we have multiple updates we need to write out to the DOM. And it's best to batch all of those together. Any real renderer will have some sort of batching or scheduling mechanism. This is not the end, though. Let's go deeper. Within the same method, if we step ahead a few lines, we can see here that we're about to schedule some work to be done in the actions queue. Following the path of invocations, we're going to immediately flush the actions queue. And this is in Backburner. This is an unexpected surprise here, but this bit of indirection is how we discover async observers are implemented. We didn't meet the conditions to enter that if block, but for now, we'll continue stepping in. Continuing to here, we'll see that flush is a function. Now, in the debug tooling, there is this little caret here. This is saying that we're at the beginning of this inline anonymous arrow function. So instead of stepping in with the debug tools, I'll follow the function reference here to place a manual breakpoint. I do this because I don't trust debuggers to step into a then or a promise correctly. Here's the breakpoint, and after clicking continue, we end up here. Usually when I do this, I'll remove the breakpoint right away. Now I want to step into the end invocation at the bottom here. Then we find ourselves about ready to flush again. I'm going to skip over flush because the queue is actually empty right now. There isn't any work to do at this time during the actions phase. This is the next interesting bit. This is when the queue advancement happens. Here we can see that we're advancing to the router transitions phase. For the sake of time, we're going to skip stepping through all of that until we get to the render phase, which is up next anyway. So here we're about to step into the render queue, into schedule auto run, now step into flush. Now we do see that async observers are running, but for now we don't care. We have to do this trick again, and stepping into end because that's what completes the work. Well, nearly. We need to step into this flush, and then into this flush, and we see that the queue itself has a flush method. And finally, here, in the queue's own flush, we have something interesting. We can see that a few things in the list of queue items that we probably want to poke at before continuing execution in the debugger. In particular, there's this function here that is passed a renderer. Let's look at that. This code is in Ember. This is good because we escaped both Backburner and the VM. So let's set a breakpoint here so we can skip parts of the queue that likely don't cause rendering. Hitting continue gets us here, and we're going to step into this render routes transaction. And in that function, the interesting part here is a single method called to render routes. And in render routes, we have this transaction, which calls render. We'll put a breakpoint there so we can hit it. And stepping into that, we land here. We definitely want to step into the render function here. And this takes us to our final location for now. This is the entry point of how a renderer is configured for Glimmer. We can simplify all of this infrastructure over time and make it easier to understand, swappable, and hopefully release an easy-to-use public API. But for now, this is all we need to know about. You now know how updates to tracked properties cause renders. With this knowledge, you can do some fun things. But real quick, we need to briefly cover how booting works. If you've messed around with the Vite blueprint, you've seen this in the index.html. Let's simplify a little further, though. We don't need to import from config environment, as we only care about booting the app, not configuring it right now. So here we remove the config, but now this file is too small, so let's inline the application. This is the minimal way to boot an app. It's still pretty small. And coming soon, you'll be able to specify services in here. So prior to Ember 6.8 Alpha 7, this is the public API option for booting applications, even if all you have is a single component. And after and including Ember 6.8 Alpha 7, we have this new API, render component. It's much simpler than the technique of making a whole application. So what have we learned so far? Debugging, patching, how rendering works, and now how booting works. And when we put it all together, you can do anything. You unlock and unblock your imagination. You are limitless. This REPL here renders an Ember app inside an Ember app. This is not an engine because I needed the outside of the REPL to not share any app-wide state with the host application. It doesn't use render component because I need a separate renderer for the right-hand side. This right-hand side often crashes due to rendering incomplete code every couple hundred milliseconds as you're typing. If I were to use render component, I'd receive this error about something unrecoverable in the VM. But when using the whole application approach, Ember currently forbids rendering a whole app inside a whole app. So I patched that out. Render component causes this error for good reason. It's because of an optimization. It shares the same renderer of the host Ember application if one exists on the passed-in owner. The fix for this behavior with render component will likely be a new syntax. Template-based try-catch. It doesn't exist yet, but has been explored once or twice by Yehuda. This is something that may need an RFC to discuss exact behaviors, like what information to expose in the error block param. In any case, I need it for making the REPL better, and hopefully now I'll have some time to help ship some version of this eventually. With the current implementation of the renderer, it's a little too complicated for a patch. So here's the patch I'm using in the REPL. And this is needed because I'm using the boot whole app just to render a component approach. And I've removed the code around asserting against nested applications in the event dispatcher. Which reminds me, encountering this sent me on a mission to eliminate the event dispatcher entirely. It's been a huge yak shave. Wagonet has been helping out a ton with that. It ultimately ends up requiring deprecating and then deleting a ton of pre-octane code within Ember source. Combining the power of patching with the knowledge of rendering, we can do some fun things. In this example here, we call a subtle API I've named sync for synchronize. Normally, when you want to make a side effect, you have to call a function from the template. I'll prove this works here by clicking this button and show you the source isn't lies. So that works. And let's see if the demo gods are favorable today. So open that, search for my file. There's the code. I can put a breakpoint there, click the little tiny microscopic button, and it's hit. Now, if you think I may be doing source map witchcraft, we can click the, oh, is this the original file? No, it can't be. One sec. I don't want to refresh. Whatever. You'll have to trust me. I didn't do source map witchcraft. I don't know how to do that anyway. All right. But yeah, so that was an effect. You saw the breakpoint hit. It works. Here's the patch used for creating effects. It's about 20 lines. But this is not a good implementation. This is the return cleanup function. And the demo I showed earlier, it's never called. This is one of the tricky things about effects, is that you can't just use them willy-nilly. You need some way to dispose of them and a time to dispose of them. So ergonomic effects necessarily need to be tied to the rendering and ownership system. This is actually very similar to the flush async observers code we saw earlier, and observers have cleanup configured due to how they can only be used within a class that already has destruction and ownership linkage. However, for all the reasons that observers are a situation in app code, so too are effects. Now, last year at Emberfest, I said there's no technical limitations preventing Ember from being used in other places. Now, this is more true today than ever. But even back then, all anyone needed to know to integrate Ember into another project was how to boot it. There isn't any need to know how rendering works to get the basic integration done. I made the Astro integration linked at this QR code in like no time at all. Most of that time was just learning Astro. But now that this exists, I'll probably start trying to use Astro more in my projects. There's a certain beauty to making sites with static HTML as the default, with sprinkled in reactivity here and there. It's very different from building web applications. But as I have a lot of docs to write, I'm going to try exploring what else can be done. So this is the whole minimal integration. This is essentially 2 lines, and the rest is well-documented Astro boilerplate. And then if we want to integrate with Astro's props, we need to come up with a way to dynamically pass them. We need a stable reference, as the template here at the top from the template compiler must have statically referenced arguments so as to not re-render unneededly. This technique will likely be similar for all integrations with rendering Ember inside React, Vue, Svelte, or Angular. So I have another live demo, and I don't know if folks know what this icon is, but that's sort of a clue. I wanted to show this file. So I'm going to invoke this starch. We're going to call node, and we're going to ignore all those flags. And we see that we're passing a GTS to the node file. So let's look at that. So we're using render component. We're passing hello world, this component, into render component, into a document body. Now we're going to invoke this from node. So there might be some sus things going on here. But so if I run bin starch, we get a little clicker thing. And then here we have Ember running in the terminal, and I can just click that. So yeah, so there was a file I wanted to show you. So the attentionally astute among you may have noticed this button doesn't look like a regular button. It's this thing. So if we go into here and skip over it, because I don't want to show you my dirty code, the way I'm rendering text here is to extend window text, do some terminal things here when it's created and updated, and then we set our own create text node. And yeah, Glimmer uses that to render stuff. So that's pretty cool. All right. All right. All right. So this technique done here to render the CLI does require some rendering knowledge, but the TLDR is that if you wanted to pursue this yourself, you might want to do what I did and re-implement browser APIs in Node and adjust how they render to adapt to the needs of the terminal. I did try looking for a project that already did that. Didn't quite find anything. There is some similar inspiration out there in the React ecosystem, like Ink. That's pretty cool. I think they're also implementing the browser in Node for the terminal. It's silly. All right, so what's coming next for Ember? I want to enable more experimentation, not just for me, because I think it's fun, but for everyone, so that everyone can experiment and use Ember in more than just web apps. So I have a plan. 3 years ago, I said I would write the resources RFC, and I finally did it a couple months ago. I've also opened a cell RFC. Both of these were in relation to Starbeam and trying to align Starbeam's efforts with how Ember works today, incrementally adding features to Ember until one day we suddenly had Starbeam. But in opening these RFCs, more questions have been raised about the core of our framework. The RFCs were sort of implementation defined rather than public API defined. Like, we can say at a high level what happens, but we haven't been able to describe in deeper detail without diving into private APIs. And all of Glimmer VM is private. We need public APIs so that we can assure that the described and well-tested behavior of those public APIs does not break anything for our users in the future. So to say my dream for Ember has gotten a little ambitious is perhaps an understatement, but I think it's still achievable. Def not by myself, doing each of these bottom integrations here, but working with the community to adapt Ember's architecture to work with everything. We want to be able to explore swapping out our current renderer, the Glimmer VM. I want to continue the exploration that Starbeam started, as well as the research in Glimmer Next, so that we can not only boost our base rendering speed, but also compete on render performance with our peer frameworks, as well as also become a universal framework without changing any public API. In particular, for my own side projects, I make a lot of dinky CLI apps, or CLI. And I would like to use Ember in a CLI environment, beyond the demo I showed just a little bit ago, but serious, or seriously dinky CLI apps. I also have had a bit of an itch to explore 3D or gaming environments, as web interfaces are, to be reductive, just rectangles. What TC39 signals and Starbeam's research, and with how long it takes all the frameworks to coalesce, and with how everyone currently has different reactivity. Even if everyone calls things signals, they behave different from each other and are different APIs entirely. Ember can become the universal glue and orchestrator in all the chaos that is the broader JS ecosystem. RFCs and community collaboration pending, of course. And now that Vite is shipped, a lot more opportunities are open to us. So here are some action items for both you and for me. It took me 3 years to put up the resources RFC, and it wasn't bad. It was mostly just me struggling with my own activation energy. It took me a long time to convince myself to spend the time. And now that I've done it, I do wish I would have done it sooner. But hopefully, before 3 years shows up again, I can make better progress with help from all of you, of course. Here's the software I used to make this presentation. Thank you for listening to me ramble.
Thank you. Are there any questions? Then we can listen to you ramble a bit longer. Yes.
Preston, thank you for the talk. I'm curious what could be possible to do for Ember to be run like on native iOS or Android. What needs to be prepared for that?
Yeah, so there's a couple different paths we could go. You could, if you wanted to do something today, re-implement the browser in an iOS or Android environment and kind of just redefined what create text node means and all that. Or so like right now, some people, mostly Ed actually, is working on merging the Ember and Glimmer monorepos together. And that will allow more rapid experimentation so that we can kind of try to figure out what the API for a swappable renderer is and figure out what our core rendering APIs even should be. So kind of like the longer term path there would be to like figure that out and then see what a proper non-hacky version of rendering for iOS or Android or other environments would be.
In that case, thanks again so much. We'll get Anne set up. One more round of applause for Preston. Thank you.